Welcome back. Now we're going to get into the Chapter 7 content. We've got kind of two parts to the content. The first part is about users and groups and those sorts of things, kind of a little introduction to the Linux security model. Second part is about file permissions and how we manipulate those things and how we read and understand them. So both very, very crucial. I'm going to avoid the stuff that is more kind of system administrator kind of stuff. We'll only just touch those things because this is not a system administration class. It's a command line interfaces class, a command line familiarity class. So we'll focus on those things, but we can't avoid them entirely. So we'll at least have a quick look, and then once we're done looking, we'll move on to other things. So very quickly then, where are the where's the information about users stored on a Linux system? Generally speaking, it's in a file that's in the etc. directory, which goes by the interesting name password, but without the O and the R, like this. And if I just concatenate that to the screen using the cat command, you'll see we get a fair bit of output. It's not that much, right? Just, I don't know, 30, 40 lines, something like that. And you'll see that there's a line, basically. Some of them, of course, wrap, but that's still technically on one line, like this one, for example, that specifies either a system service or a user. So this is a system service called systemd-network. Okay, and here's some information about it, and indeed this part that I'm highlighting now is kind of a description of what it is. Those really we're not that interested in. Let's go down a little bit farther and let's look at the users that have been added to the system that are not system services. How do I know that they're not system services? Well, first of all, there's my name, so that's probably a good hint. But on Mint, they start here like at in the space of 1,000 and above, it seems, although here's 999, and that's something that VirtualBox is using, but presumably that's a service. User 1000 then is where the is where we begin here as we add users, and you see I've added a couple of others over time. But the information here, this is obviously my login name. This used to, historically on Linux systems, this used to hold the password hashed, but that is no longer the case. That's stored in a different file now. We'll take a look at that here in a little bit. This is the user ID. This is the group ID. And this, I think this might be a just the description, and I don't know, why the comma delimited fields that are empty. I'm not sure. This is this user's home directory. We've seen that before, and this is this user's default shell. All of these, of course, are separated by colons, as you see. And likewise for various others, here we have a user called test2, and you see this one has a home directory, but there is no default shell for this user that's specified in this file. So those are what the fields mean. What about the passwords? All the passwords, it just says X. Does that mean everybody has the same password and it's X? No, it does not. What it does mean is that's no longer where that information lives on Linux systems. It's put in a file that requires a little higher privileges to access. And that file is the etc. shadow file. So if I type cat / etc. / shadow, I am told that permission is denied. What to do? What to do? Well, now we're going to look at a command that will allow us to escalate privileges and actually give us root privileges on this device. With root privileges, you can more or less do anything that you want. And that command is the sudo command. And so I can, and it's spelled like this, sudo. You look at that, you might say, well, that looks like sudo, because that would be like other words in English, right? Most words that end with a do, like judo, it's a long O at the end. But this is sudo because it's su, whatever that means, and then do something. Okay, so like the verb do. So the usual pronunciation is sudo. And you can look at the man page for it. I'm not going to belabor it much. But basically, sudo, well, here it is, allows a permitted user to execute a command as the super user, hence the su part, right? Or as another user, as specified by the security policy. So you could specify a different user to execute something as, and then you'd have to put in the password for that user in order to be able to execute that command as that user. But you'll need a password to do it. Let me exit and I'll show you what I mean. We were not able to look at that file, but if we were root, we could do it. So we can say sudo before that and then execute the command. And what we're saying is execute this command not as me. I'm not asking on my own behalf, but execute this command as the root. And so what it's going to do is ask me what is the password for the user who's associated and able to escalate to root. And so I put in my password, and boom, now I get to see the file. Okay, so it outputted the file for me. We're going to use that sudo command rather frequently during this chapter for a lot of the stuff we're going to do. We're going to be adding users and groups and things like that just a little bit, just to touch them a little bit. And those things will require escalation of privileges. The reason for that, of course, is for security, so that your basic user account isn't able to do things that make wholesale changes to the system or that might compromise security. But rather, you kind of have your own sandbox that you can play in. I'm not saying that as a regular user you can't mess up a Linux system. I'm quite sure you can, but it's tougher, and so that's the idea, is that becomes more difficult. So if you get malware that you install on the machine, it's running as you, it only has the same privileges you have, etc. So there's a lot to the Linux security model. We're not going to get into it in depth. When you're in an ethical hacking course or something like that, trust me, you'll learn about it in depth. But for now, as I look through here, here's my user ID, and here is the representation of my password then that Linux has stored. My password uses only 4 characters, and this thing looks like that. If it used 40 characters, it would still look something like that. It would just be a bunch of different symbols. So obviously that's not too useful to someone, and cryptography and hashing and all that kind of stuff are a conversation for a different time and a different context. But in any case, trust me, it's really hard to take that and to get a password back out of it. Hard enough that even governments generally don't try it unless it's an extremely valuable thing that they're trying to accomplish. So there are better ways, frankly, to get passwords, like look at the sticky note that someone sticks underneath their keyboard, because usually it's going to be there, right? Or if that doesn't work, let's try the million or so most popular passwords and see if we get a hit. So there are lots of other ways to go after passwords than that. But anyway, there's the password. I don't know what this other stuff is in here in the shadow file. Not sure what it is, but there it is, etc/shadow. So, okay, let's go ahead and play with users a little bit. First thing we want to do is add a user, and the way we would do that is using the user add command. Isn't that convenient? User add adds a user. I'll use the -m flag here. What that does is it copies from a template stuff to stick into the home directory of the user that's being added. So, you'll notice if you installed Mint that within your home directory you have documents, downloads, a variety of things like that that are kind of pre-populated for you. You didn't have to make those. And if you want that template to carry over for a user that you add, if it's like a human user that you're adding, then you would use the -m flag to do that. And there's a template, you can read about it in the book. There's a template file for that. It's called Skell. It's basically a skeleton of the structure that would be copied over in such a case. You could have other files in there too, not just directories. You could have certain files, profile or .bashrc and that kind of stuff. Or you could have other files like our employee cybersecurity policies or something. Might be something that gets copied over, whatever. So that can be as full as an organization wants. But anyway, so we'll user add -m, and let's make a test. We'll call it. We'll call this user. How about Kitty? I don't know why. I just thought of my cat because I just fed my cat a few minutes ago. Okay, you come up with a name then. All right, so there it is. So we'll add the user there, and what's going to happen? Permission denied. Cannot lock, blah, blah, blah. Okay, so the second message isn't as helpful. Try again later. It doesn't matter. You can try again as many times as you like later. That ain't going to do it. The first message right here is the crucial one, permission denied. Why? I don't have the right as a normal user to add users to the machine. Again, that's a security precaution. So I need root access to do that. So what I'll do is you set it sudo, right? User add, and now then I have a new user in the system. So how do I know that the new user got added? Well, I could just hello, okay, cat / etc. / password. You know what that's going to do, right? That's going to generate all that output, etc., right? Here it is, and you see that one right there at the bottom. Since the user was added at the bottom, this file seems to append things to the end, can you think of another tool that I might use to get a little less output? What if we use the tail command? Remember that one? So see, the tail command only gives me the last several lines, okay? And in fact, if you look at the man page, you'll see you can specify how many lines, etc. In fact, why not? Let's just look real quick. Let's see if we can figure out how many. How about output the last num lines? So -n is what we're looking for, and then presumably it'll be -n and then a space and then the number. Otherwise, by default, you see it's the last 10. Let's try it. Tail -n 1 and / etc. / password. There you go, the last line. That worked. Nice. This is how you kind of find your way around the command line. You want to know more about some of these commands? Tail does more than just output the last 10 lines. It can output the last 1 lines or whatever. There's more stuff. You saw those flags or options that were available for tail. -n is just the beginning. This is how you learn this stuff. You have to be a little bit curious and try it out. Okay, so that's one way to do it. Can you think of another way to do it? What about using grep? Remember that? Sure, we could do that. I know the name of the user, right? And there it is. And it highlights the things that match, but certainly that's only going to occur on one line in that file, unless we had another user called Hello Kitty or something. No, just kidding. Okay, so moving on from there, probably we should add a password for this user, right? And once again, we're going to need sudo for that. So password is spelled once again without the O and the R. Not sure why that is. I guess just because it's too much trouble to type the other two characters. And so we'll sudo password for Kitty. We're going to change Kitty's password. Wants to know a password. Okay, good. I'm going to give it one. Okay, and type the same thing again. And it says password updated successfully. So now Kitty actually has a password. So I could log out as me right now if I wanted to, right? And just go down here to menu. And this is the one for log out. See, it says it on the right here. See the little, you as you mouse over things, you get some things anyway. You get a helpful little tooltip over there. Log out, leave the session. So if I did that, I could log in as another user. In fact, let me just show you what it looks like. Why don't we just do it? You can log out altogether, which just leaves it at a login screen, right? I can say switch user. So this might be better. So that's Perry, that's me. I've got another one here called test2, another one called Copus test. I've been playing with users, but I can go to the Kitty one and put in the password, the very clever password that I selected for that account. And I'll take a minute because this is the first time logging in as this user. So yep, and there we go. And you see I've got the welcome screen and all that stuff. And everything available to the user. See, it's no longer Perry VirtualBox, which is the name of this machine. Very clever name. But now it's Kitty. Okay, so the other account now is there. And see, I don't get my defaults either on my terminal with the larger font and the bigger size and all that. All that stuff is gone because this is a different user. So different users have different stuff. Let me just go ahead and log that user out. I'll just switch user. Switch user is good because basically I never logged out. I'm still there. I just need a password to get back in. And now we're back to me, right? So if I logged out altogether, it would close everything, but if I just switch user, all my stuff is still there. Okay, so that's very handy. We've got the possibility now of adding a password and then switching between users, etc. So what's next? Let's talk about groups. So first, I'd like to show you where the file lives for groups. I'm going to use the less command this time. I'm just trying to work my way around the different ways to look at things so that you can remember some of these tools, because you need to be familiar with all of them. Remember, less will give us paginated output. We can go up and down, etc. Very handy from the command line. So we want to look at the file slash etc slash group. And now we'll see the groups that are here in this on this system. And so if I go all the way to the bottom, you'll notice that Perry, for instance, is a group on here. You say, well, wait, Perry's a user. Yeah, Perry's also a group with the ID 1000. Okay, and I've got some others that I did. Here's a test group and a test 2. And Kitty is also a group because there's a user called Kitty. Okay, and that's group number 1004. And so that doesn't necessarily correspond to the user ID, okay, but there's a unique ID for each user, there's a unique ID for each group, and there are other groups here obviously as well. Okay, so type Q to exit less, and let's add a new group. Okay, so I'll say group add, rather convenient. You know, what you want to do, add a group. What command would you use? How about group add? Okay, makes perfect sense. So we'll add a group called CS1500 if you like. Okay, and whoops, can't do that. What do I need to do? Right, you got it. At least hope you're getting it. We have to escalate privileges. We'll do that. Notice it doesn't ask for my password now that I'm adding that for these other commands. The reason is that Linux makes a certain assumption. If I've already provided that password in the last several minutes or something like that, it's, you know, within this console, it's not going to ask for it again because it's assuming that the same human being is sitting there, and so I'm already basically kind of authenticated here. So okay, so I did that, and now we should have another group, right? So if I take a look at that again, I'm going to go to the bottom because that's where it's going to stick it. There it is, CS1500. There's the group, and it's group ID 1005, right? So what can we do now that we've created a new group? We could move a user to that group, or we could add a user to the group, or we might also modify a user in such a way that we make it their primary group. So what am I talking about? Well, let's just take a look at all of the stuff that's in this directory right now. We're just in my home directory, right? And you know, let's take a look at some of the files that I've created, like this one. There's an archive file, right? A tar file that I created at some point, and a rather big one actually. I probably need to just delete that because I was just playing around. But take a look at this. Remember, we're going to talk about these permissions and things first. The first character here is the type of file, right? Dash is a regular file, D is a directory in this list. The next 9 characters that follow are all of the permissions, and we're going to talk about that next. But let's skip over to these 2 columns where everything says Perry Perry, right? Looks like a stutter, but in fact, there's different information being imparted by this. The first one indicates the user, the ID or the name of the user, the login ID of the user who owns this file. So this is the owner of this file. This is the group associated with this file. So every file has an owner that owns the file, and that means, you know, basically is in control of that, created it, etc. And then there's a group associated with it. The group has access to the file for certain things, and that gets into these permissions, which again we'll talk about in a few minutes. So user and group. Remember, we saw that there was a user named Perry and there was a group named Perry as well. And it'll be the same for our new user Kitty. There'll be a user called Kitty and a group called Kitty. Not terribly interesting when it's like that, when the group is the same as the user, right? But we can associate these things with a different group, and by doing so we can allow an entire group to be able to do something with that. The group could be all the people who are in a certain department in a company, or some other group of people, some other grouping. It doesn't really matter. It could be certain programs or services that run. So in any case, let's see first of all how we might change a user's primary group. Now, what's my primary group? My primary group is Perry, and so when I create anything, that's the group that's associated with whatever I create. Okay, but and I'm not going to change mine, but why don't we modify another user? What command do you think you would use to modify a user? How about user modify? So of course we'll need to escalate privileges. It would be user mod. That's the user modify command. Okay, and then we make our modifications. So before we do that, let's just take a look at the man page. Man for user mod. Okay, so looks like user mod with a -a will add the user to certain supplementary groups, groups. Okay, so we can append to groups. Use only with -g. Let's take a look. Let's go back a little farther. You can set the user's login directory. Where's the user's home, in other words? So you can change that. There's ways that you can expire or require a user to be flagged as inactive and basically lock them out in certain cases. Look at this -g, the group name or number of the user's new initial login group. The group must exist. So this is the group that this user will be primarily associated with. Look at this. Any file from the user's home directory owned by the previous primary group of the user will be owned by this new group now. And the group ownership of files outside the user's home directory must be fixed manually. So those will still be owned by whatever the former group was. So in the case of our user Kitty, anything outside of the user's home directory that's owned by Kitty will still be associated with the group Kitty, but anything within the home directory is going to be whatever we're going to change it to. Well, let's change it then. Why not? Let's do it. Sudo user mod, and we said that was going to be -g, and what did we add? We added a CS1500 group, right? So CS1500 is the group, and the user associated with this change, of course, is Kitty. I think that's about right. Let's see. So we did that. And now then, the Kitty user, everything in the Kitty user's directory should be associated with the CS1500 group. So that's cool. So now, what good does that do us? Well, I ought to be able to also add files to that group if we want to, and perhaps also add myself as a user of that group, and now we can do some file sharing and other interesting stuff. So let's go ahead and do that. Why don't we take a look? And by the way, if you want to know what groups a user is associated with, you can use the ID command. So this is an easy way to do this. See what users the user is associated with. So here's the user ID, which is Kitty. Here's the group ID, 1005. CS1500, that's the primary group, and now here are the groups that this user is associated with. There's only the one group, CS1500, right? Because we just changed the primary group of this. Let's take a look at another one. Let's look at Perry, and you see quite a few more. Now, I didn't set all of these up. I did set this one up, test group, okay? But these others, like administrators, CD-ROM, sudo, dip, I don't even know what dip is, plugdev, lp-admin, samba share, those were set up at the time that that this system was first installed, and it asked for the administrator, okay, you're the administrator, you're the one in charge, what login do you want to use? I said Perry, and it set all of this up and added me to all of these groups because I'm the administrator of the machine, okay? So those are already set up. So how do I add another without changing my primary group? I don't want to change from the Perry group being my primary group, but what I might like to do is add the CS1500 group so that I can read all of the things in Kitty's directory now that we changed Kitty's primary group, right? No, we'll just do this so we can demonstrate sharing stuff, right? So how would I do that? It's going to be the add user. Now, notice this is not the user add command, right? This is the add user command. So, yeah, it can be a little confusing, right? What does add user does? Add user adds a user to a group. Okay, what user? Perry. Okay, what group? CS1500. Okay, so there it is. Nice and easy. And now we got that done. And so let's go ahead and ID Perry again, and you'll see that now Perry is part of the CS1500 group. Very, very, very easy, right? So now then, why don't we go ahead and just take a look at the files here. Nothing here well, here's a file with 0 bytes called this file. We're going to pick on that one because I think the next thing we'd like to do is see how we might change the group that owns this file to CS1500. Why would I want to do that? Because I want Kitty to be able to access this file, right, and not be able to access anything else. But right now it's part of Group Perry. Kitty doesn't have access to Group Perry, and that's exactly the way that we want it. Okay, right? Because we don't want just everybody being able to willy-nilly see everybody else's files, right? Okay, so how do I want to do that? Well, this is going to use the change ownership command, and it's interesting how this one works. Change ownership is chown, but you can see the two parts there that have been elided together to make change ownership. You can do a couple different things. You can if you just type a word here, then it's assuming that that's the ID of a user, so you're changing the user. If you type a word and then a period and then another word, the first one is a user, the second one is a group. If you type a word and a period, then that's a user still. So if you type a period and then a group name, then it's interpreted as a group. Okay, so that's kind of complicated. Check the book though. It's not that bad. You just have to think about it a couple times. But since I'm changing the ownership of this file to this file called this file to this group CS1500, I'll use that with the dot first, okay, because it's the group that I'm changing. So I want to change the ownership to this group of this file, like so, okay. And if I now take a look at this, you will see that the group now, see it, it's changed for the thing called this file. Why don't we go ahead and do something with this? I'll use the nano editor for this. Okay, and what I want to do is just add something. Hey, this line was added by, well, lowercase, right? Since that's the user. Okay, so I'll do that. I'll hit Control O and Enter to write it out, and then Control X to exit. And why not see what's in it, just to show you that it's there. Okay, so that's pretty easy. Why don't we go now and we'll switch users again. So I go to Menu, this one right here, Switch User. Let's log in as Kitty. How about I make that a little bit bigger? Remember how to do that? It's Control-Shift+ and then Control-. We'll get that for you. So what do I want to do here? Let's cat. Now what do I need to do? I want to actually see the contents of that file. It's shared. I should be able to see it, right? So let's see. Let's catenate. What would it be? Slash home slash Perry slash this file. Wasn't that it? I think so. Ooh, permission denied. I wonder why. I think our problem may be that we simply switched users, but we did change the group of the user. So let me log out altogether and then log back in. Since we did change Kitty's primary group since last time. And there it is. So there's the file. So now if I take a look at the file there, and let me just grab that, Control-Shift-C, Control-Shift-V, because I type so darn slow. So there it is. Fact of the matter is I have permissions also to modify this file. We'll look at that here before very long. But let me just go ahead and edit this file. And let's add another line. Oops, it's Kitty, like so. And Control-O, Control-X to exit. We'll exit, and let's just go ahead and log out. And we'll log back in as Perry. Okay, and so now do the same thing, and obviously we have the change. So we're able now to share files between users. Why? Because these users are within the same group, and that group owns the file. The group is CS1500. Now, even if I was not myself a member of the group CS1500, I would still have access to the file because I'm actually the file's owner as well. Okay, so I mentioned that this file we had access. I looked to make sure that it was the case that Kitty would be able to write to that file, and just by simple inspection of the long listing, so ls-l, I was able to tell that was the fact. So how is that? That was because I read this information that you see right here, and I'm going to teach you to read it right now as well. It's really not very hard, and the description in the book is pretty decent too, but let me see if I can take a crack at making it really efficient. Remember, this first character indicates the type of the file, so don't think that that's part of the permissions. A dash means that it's a regular file. A D means it's a directory. There are some other types we'll see from time to time, and we'll talk about them as we come to them when they're important. Next, what we have are 3 sets of 3 characters. So this is RW dash, then I've got RW dash, and then dash dash dash. Okay. Now you'll notice that others, like this file right here called test, okay, is a little bit different. This one, its 3 sets are RWX, RWX, and then R-X. Okay. So these represent the permissions for 3 different groups. The first set of 3 represents the permissions for the owner of the file, and that's associated with an ID, a user ID on the system. The second set of permissions are with respect to the group, so that's associated with the group that owns this file. In this case, the group is Perry. Remember, there's a group called Perry and a user called Perry. So the user is Perry and the group is Perry. These are the permissions for the user Perry. These are the permissions for the group Perry. Not the same thing. They're 2 different things. They just happen to have the same name. Go down to the next one. It's a little more obvious. These are the permissions for the user named Perry. These are the permissions for the group named CS1500. Okay? Now then, the third set, in this case, dash dash dash, up here it's R-X. The third set refers to anybody else on the system. Okay, anybody else on this system, what permissions do they have? Okay, now having said that, now you know they're grouped in 3s. Let's look at the possibilities. Each one of the 3 characters has exactly 2 possibilities. For the first one, the possibility is it can be an R or it can be a dash. R or dash. The second one, the possibilities are it can be a W or it can be a dash. The third one is it can be an X or it can be a dash. Those are the possibilities. Okay, so for each one, I've got 3 right here. That could either be an R or a dash, the first one. That could either be an R or a dash. It can't be anything else. Okay, it happens to be a dash. This one could be a W or a dash, and it happens to be a dash in this case. This one could be an X or a dash, and it happens to be a dash in this case. Again, going back to the prior set for the group. This one could be an R or a dash, happens to be an R. This one's a W, could be that or a dash. This one is a dash, it could be that or it could be X, right? Okay, so what do these mean? Well, R means that we have read privileges. That means we can see the contents of the file, but it does not imply anything about being able to change the contents of the file. That's for the next one, which is represented by W. Write privileges. That's write as in, W-R-I-T-E, like what you do when you take out a pen and you start marking up a piece of paper. You're changing the paper, okay? To have write privileges for a file means you have the ability to change the contents of that file, right? There's also some connection to deletion of the file also. And then the third one is execute. And when we get to scripts next week, we'll start talking about that execute privilege. So I'll just say now that it just means, can somebody run this file as though it's a program in some way? Again, we'll talk about it next week, so I'm not going to spend a lot of time on execute. But those are the three possible permissions, and there are three possible entities that we're concerned about: the owner, the group that owns it, and then finally anybody else on the system. So as we look at this file, the way we read this is the owner, who is Perry, can read the contents of this file or write, that is, change the contents of this file. Okay, so that's pretty much total control over a file that isn't a program. Okay, that's not a program, it's just a file that has some, hey, Perry changed this, whatever. Okay, it's just text. So read and write privileges kind of cover the gamut of things that I might want to do with the file that I own. Also then, the group has the same privileges, read and write. And if that were not the case, if it were only read privileges, then when I tried to edit the file from Kitty's account, I wouldn't have been able to edit the file. All right, it would have failed and told me that it was not able to write to the file. It would fail because Kitty doesn't have permission to do that. Okay. Now then, finally, any other user on the system, they have neither read access nor write access. So what that means is, if I log in as another user, let's say, I don't know, you come up with a name, use your name, fill your name in. I'm out of ideas. But anyway, if I logged in as another user on this system, then I would not be able to see that file or use the cat command to list it or anything like that. I wouldn't be able to read it, nor would I be able to change it, of course. Okay, so that's the essence of it. Now, as you look at some of these other files, then these are directories, right? Like pictures is a directory, and we see read, write, execute, and read and execute, and read and execute for others on this system. And so there are some defaults kind of set up for these directories. Okay, so how would we change the permissions of one of these things? Well, there's something that you need to know in order to do this, and I'm going to direct you to the text to take a look. Let's see, I have to find it real quick. It's in chapter 7, there it is, page 178. And you want to have a look there at table 7.5, the Linux file permission codes, because there are a lot of ways of doing this, and of course you should look at the text. There are different ways of changing permissions, but the best way for you to learn what you need to know to do this is to memorize certain parts of this table. I'm going to tell you the parts of the table that I think you should memorize. First of all, if you look at the first column, you don't have your book yet, hit pause, go get your book, come back. Okay, so look at the first column where it says permissions. Those should look very familiar to you at this point. You've got dash, 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 X. It's basically all the possibilities, because you've got 2 possibilities per thing. That means there should be 8 lines in this table, which there are. Okay, so basically you're going from no permissions all the way up to full permissions in the lines of the table, right? And then those represent a binary condition. So if you know binary, that's fine. Then that'll make some sense to you. If you don't worry about it. It's not going to be essential for you to know. Okay, but it might help in understanding what's going on. And then next is the octal representation. Now you already know what R, W, and X mean, okay, and what the dash means. So all you really need is to figure out how to map those to an octal value, because that's how we're going to change permissions. You have to know that octal value right there. This is the easiest way, frankly, to do this quickly. And I'm going to tell you the ones that are going to be most frequently used that you really want to commit to memory early, and then later on you'll kind of learn the others just by doing and just by kind of immersion, okay? But the ones that you want to memorize, dash, 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 no permissions is a 0. That's pretty easy, right? That makes perfect sense. These numbers, you notice, go from 0 to 7. So full permissions, that's a 7. See that at the bottom of the table? Now go up 1. Read-write permissions but no execute permissions, that's a 6. Now then, the next really important one is read-only permissions. Go up to line 4, or line 5, I guess, and it's the octal 4, right, is for read permissions only. Those are the ones that are going to be most commonly done. That is 0, 4, 6, and 7. Those are the most common ones. Now, the others are important too, but again, you want some economy in what you need to learn. Learn those, 0, 4, 6, and 7. So what does that do for us? Well, I can use that number to represent the permissions for a particular file with, I can use just a series of 3 numbers, one for the owner, one for the group, and one for the for everybody else, right? And so let me just make a file, okay? Touch some file, right? And if I say ls-l some file, there it is. Those are the general permissions. I say, okay, those are the default permissions for that file, but I'm going to perhaps change the group to some other group. Maybe let's say sudo cs1500 and some file. Okay, so see, it took a little while, so it's asking for my password again, right? So now take a look at it. You see that a different group is owning it. But now I'm going to say, okay, people in the group, I want them to be able to access that, but they should only be able to read it. I don't want them to be able to write the file, only read it. So as I look at my permissions, that's the owner. I want to read and write. I want others to be able to read this file but not write it who are in the group. And anybody who's not in the group, I don't even want them to be able to see this file, right? So what does that mean in terms of the permissions that I actually want? Well, I want me to have read-write access. Look at your table again, and you'll see that's the octal value 6, right? So here's what I'm going to do. I'm sorry. It's chmod, change mode, okay? So chmod, and the options that I want, I'm just going to type an octal number, okay? That's 3 digits. So the first one is, I want read-write access for the owner. That's me, right? That's 6. I want read-only access, read-only permission for the group. What's that? Look at the table. That's 4, right? And I want no access for anybody else. Well, no is easy. That's 0, right? So 640, some file, okay? And let's take a look at it. Check it out. Now our permissions are set for that file. You need to be familiar with the table. Why do you need this? Because you need this all the time. All the time you're going to be using the chmod command to change the permissions of a certain file, to make a file that's just a text file executable when you make scripts. I mean, all of these things. Okay, so you need to learn this particular command. Since you now have your book in front of you, do take a look at the next page. So we've kind of covered a little bit starting on page 179, but if you turn the page, there's also another way that you can add permissions or subtract permissions or make the permissions equivalent. So I'll give you an example of that. So this is the content that's on page 180. You need to read and understand this, but I'm just going to give you a quick example. So now we're going to change the mode in this way. We're going to allow others to have the same privileges, that's what equal means, as the group, for instance. Some file. And if I look at that, you see now that others have the same. That's what the equals means. What if I want to subtract the read access? That's easy using this mechanism too. If I just want to change one thing, it's really easy. I would just say chmod others minus read and some file, and take a look at that, and now they no longer have read access. Okay, so learn both ways of doing this. If you need to just tweak one of these values, this is probably a quicker way to do it. But learn the octal values too, because it's really handy to totally change everything all at once. So we're at almost 50 minutes for this section. I think that's quite enough. The Chapter 8 content, what do I want you to know there? You know, we're not trying to become system administrators in this course. That's for a different context. But at the same time, it's good to know at least a little bit about this. So there's one question in the homework that comes from Chapter 8. So what do I advise you to do? If you're really interested, of course, read all of Chapter 8 and read it in detail. If you're kind of ready to move on to other things and you've got other obligations that you need to deal with, skim it. You just skim the content. That doesn't mean ignore it altogether. I don't think that would be a good idea. But skim it, and let's be ready then to move on to the subsequent chapters for next week. Have a good week.